For this one, since these are different trig functions, I can't use those intervals. I'm going to have to start with the innermost parentheses because of PEMDAS. Since it's inverse sine, I know I'm limited to quadrants 1 or 4 only. And since this is positive, I'm going to be in quadrant 1. Now, root 2 over 2, it's a lot easier if you remember that root 2 over 2 came from 1 over root 2. 1 over root 2 simplified to give me that. So you could use your triangles, your 30, 60, 90, and 45, 45, 90 if you want. Or for some people, it's just easier to draw a picture. If this is sine is so opposite over hypotenuse. And I'm going to draw a picture in quadrant 1 because that's where we determined that it belonged. So opposite of 1, hypotenuse of 2. You do your little Pythagorean theorem. This is just my 1, 1, root 2. So my 45, 45, 90, but of course we're staying in radians. So pi over 4, pi over 4. But since this picture is representing this whole inverse sine of root 2 over 2 now, all I have to do is find cosine of my picture. So that's why I like to draw the picture, because I can just look at it. Cosine is ca, 1 over root 2, and then of course you just simplify it, so it would be root 2 over 2. So that's how you get the root 2 over 2. For number 23, these are the same, so you can use these intervals that are listed on that one sheet I gave you. Since inverse sine is on the outside, you have to make sure you follow the correct one. But basically, this is the answer as long as it fits this stipulation. So if I have to be between negative pi over 2 and positive pi over 2, this is my setup. Here's positive pi over 2, here's negative pi over 2. I have to be in quadrants 1 or 4. Now, negative 7 pi over 6, if I graph that, if this is 0, first off, if I graph negative, I'm going down. So this would be a negative pi over 2. If I keep going, this would be a negative pi. And if they're talking about something out of 6, a whole pi would be negative 6 pi over 6, right? 6 out of 6 is a whole. So if this is negative 7 over 6, that means I went the negative 6, and then I went a little bit more. So I'm actually in this quadrant. So clearly that's not the answer, but I need to take this and bump it over to quad 1. So if you think about it, we went all the way to negative 6 over 6 pi, which is a whole, but I needed negative 7 over 6 pi. So to get from 6 to 7, I went 1/6 of a pi more. So if I went 1/6 of a pi more, basically 1/6 of a pi is it's 1/6 of a pi, that falls in quadrant 1. So it's a little bit over that you went, because if you drew like a little picture, this part here would be the pi over 6, which would be the mirror image into quadrant 1. So pi over 6 is actually your answer. So again, I did negative 6 over 6 for a whole, but I had to go 1/6 more, and 1/6 of a pi, sorry, that noise in the background is my dog, 1/6 of a pi over, that's the reference angle, and reference angles happen to fall in quadrant 1, so pi over 6 is between the 0 and half a pi, so that's my answer. So that one's a little weird, but again, if it doesn't fit, you have to make it fit. And if we talked about in the one video, I don't know if you saw, but if you type this into your calculator and you ever get a go-to error, that means you cannot make it fit. So those ones would be no solution. But if it gives you a value, that means you can make it fit, and you do that little kind of leapfrog game to make it work. For 41, I have the inverse secant. So right away, I'm limited to quadrants 1 or 2. Since this is positive, I'm in quad 1. Now this one's weird because once I determine it's in quad 1, I'm going to flip it to the brother-sister pair, which means I have to flip this. But that means I also want to simplify this. So this is why it's kind of odd. So I flipped it because I wanted to go to the brother-sister pair. I'm going to multiply to get the root off the bottom. So now I have the inverse cosine. This would give me 3 root 3. Here's the 2. Root 3 times root 3 is root 9, which is just 3. These 3's cancel. Now I have inverse cosine of root 3 over 2. Even though I switched it to the brother-sister pair, I'm not changing the quadrant no matter what. You're still doing quad 1 because I'm still trying to find inverse secant. That's what I'm really trying to solve. So in quad 1, I need cosine, which is ca, adjacent over hypotenuse, to be root 3 over 2. So I have this triangle right here. You can see if I need an adjacent of root 3 and a hypotenuse of 2, that happens at pi over 6, which also happens to be in quadrant 1. So that's my answer. And then finally, this inverse secant of 4. Again, inverse secant is quadrant 1 or 2 only. Since that's positive, I'm in quadrant 1. Think of this as 4 over 1. so you can flip it to the brother-sister pair. So it would be inverse cosine of 1/4. And this one they told you just to use your calculator, so you'll just make sure your calculator mode is set in radians. But to be in quadrant 1, don't forget that means I'm between 0 and half a pi, which is 1.57. So when you type this in your calculator, if you don't get an answer that fits, you're going to have to make it fit. When I type that in my calculator, I get 1.32, which is clearly between 0 and 1.57. So that's my answer.